Thank you, and thank you for staying the whole day. It was a day of learning and sharing, and my greatest hope is really that next year someone from the audience will be here sharing their own serverless story, and that would be really the greatest success of this event today. So serverless is something that you heard today across lots of different perspectives, but one thing that I really love of serverless is that I think it's showing us the direction where development is going in the future, so that we can focus on the business logic and less on the management of what's below the implementation of and the execution of the service. But if we have to reason about how serverless works, I think, in my mind, when I think of serverless, I first think of these fully managed services that allow you to have storage, databases, machine learning services, analyzing images or text that can run without you having to think about serverless. But these fully managed services were not really enough, because S3, for example, is an object storage has been around now for, I think, almost 14 years, but we were not talking about serverless 14 years ago. What changed is functions, like when we launched AWS Lambda in 2014. I think functions can really take the features of these services and add your own unique business logic. But how do these fully managed services and this function work together? How do they talk? They talk via events. So events, I think, is the third important component of a serverless architecture. And today we heard some very interesting stories from Jeremy or from Shin, for example, how you can use tools like Event Bridge to connect different microservices using events. And then what happens is that, for example, you upload a file on S3, you update a customer data on a DynamoDB table, and this fires the execution of your own business logic in a function. And then this function can use other services. So you upload the file, you process the file, then you update a database, this fires another function, and this beautiful chain of function, of event-driven, a really nice event-driven architecture is what makes serverless powerful and can simplify, decompose a large business problem into smaller components. But it was not always like this. So if we go back to the beginning of serverless, 2014, 2015, most of the greatest use cases that were shown at the time were image thumbnails. So you would upload an image on S3, and this would be formatted for all the different devices. And this was the greatest story of those first period. Actually, if we look at how you have to implement this architecture on a traditional infrastructure, is still a lot of complexity, the coupling the front end, the batch, keeping a high availability. So it makes sense that at the time this was important. And then people realized that you can actually use the same framework for any kind of document that you upload on S3. And since probably one of the tools we all hate is those content management systems that we're forced to use, lots of people start to build, and I'm guilty as charged, building tools that could create a content management system where you upload some static content on S3, like Markdown and images, and your website would be automatically generated on S3. And it was a very popular use cases. Then some people realized around the first half of 2015 that you can actually call Lambda directly, because Lambda has an invoke API. And at the time, you could use the AWS SDK to call Lambda. And you could use the AWS SDK also in the browser. So you can have a static page that you download, for example, from S3, calling Lambda function, and build dynamic websites and applications. This was probably the beginning of the terminology that brought this idea of serverless, because you can really build dynamic application in this way. And then we also start to see ramping up other usage of serverless. For example, Kinesis that allows you to process a stream of data was one of the first integration. But in this period, we start to see a ramp up of usage of Kinesis and data streaming with Lambda, because it was much, much easier than any other data streaming serverless processing platform at the time. Around June 2015, the Amazon Echo that was just launched at the time opened the possibility to create Alexa skills using Lambda function. And this, again, opened a completely new landscape, because building a voice-enabled application before required a very specific skill set that now it was necessary anymore, because with a few lines of Lambda, you could create a voice-enabled application. July 2015, the API gateway went out, and you could start calling these traditional web APIs without the AWS SDK straight from a browser or from other services. So it really opened the idea of creating serverless APIs around. And towards the end of that year, also AWS IoT was announced and integrated with Lambda, so you can start streaming data from IoT devices to Lambda function, process them, and send signals back. So it was another interesting use cases that was launched. And just at the beginning of 2016, the integration with CloudWatch events, that's the same engine that you can now access with more features through Event Bridge, allowed you to schedule function. And this opened lots of use cases for DevOps-like scripts, because at the time, lots of people used to have small scripts running on servers, and this is very unreliable sometimes. So the possibility of moving scripts into a reliable execution engine was really popular and moved a lot of workloads here. And even today, we see lots of enterprises that start using serverless on the DevOps side to automate their IT process, and then start to use that more on the development of new applications. And these are still very, very popular use cases today. But over the years, we got some feedback, some concern from customers. One is, OK, if I have to use these new features and build a serverless application, is this a completely new paradigm? I have to learn new things, or I have to unlearn what I was doing because things are so different? Latency, you often hear talking about cold starts, even though they impact probably a very small number of real use cases. But probably we have been guilty here as AWS, because especially at the time, if you were an enterprise, you would probably use Lambda using a runtime like Java that is not designed to be start quickly, because it was been designed for years for long-living processes. And you would probably connect your Lambda function to a VPC, and the connection to the VPC was slow, because we need to create every time a new environment for a concurrent environment for a Lambda function is created, a new network interface. So it was slowing down, and especially in development, where every time you test a new function, we get everything new, it was really giving a bad experience. So latency, it was an issue. Scalability, so this thing scales automatically, but can it scale to the throughput that I need? And maybe it's thousands or tens of thousands or even more requests per second. Language support, can I use my own version, my own language, maybe some libraries that I already have, or am forced to use only the runtimes that you provide? And cost, so serverless costs very little when I start, but if I start to ramp up and grow my application, are the costs still correct, sustainable on my business case or not? So we as AWS, we work on this concern. So we focus our innovation in a few areas. So the idea is to see how we try to address these things, especially with the more recent things that we launched, and what this is enabling for you in 2020. So let's start with the function invocations. So here we work a lot to improve the integration with lots of services. So this is just a snapshot from the console. So it's now natively integrated with lots of services, even more than you see here. But what I really like is that through Event Engine, we can now integrate with external services very easily. So here, if you look at the bottom, you can receive a notification and execute your business logic through Lambda if a trouble ticket managed by Zendesk changes state. Or you can literally page a Lambda function if something goes bad with PagerDuty. So it's really a nice way of going outside the border of what we can provide as AWS and leverage the power of all our partners. Asynchronous invocations have been really called out often today, and I think this is really interesting. So for non-experts, when you call a Lambda function, you can call it synchronously like the API gateways. The API gateway calls a Lambda function synchronously because it's interested in the result of the API to give it back. But S3, for example, when you upload a file, fires the Lambda function, but it's no interest in the result. And that's an example of an asynchronous invocation. And up to a few months ago, the idea of a return status from an asynchronous invocation was not part of the platform. We were not looking at the return value of an asynchronous invocation. This was creating some problem because how can I be sure that all my files have been processed when I upload them on S3? That's why we introduced a few features that can simplify managing asynchronous invocation. So first of all, you can now tailor the number of retries. Before we were retrying 2 times with an exponential backoff, as Sarah was saying. Now you can limit the number of retries and the maximum age of an event when we continuously retry for multiple times. We already introduced the concept of that letter Q so that if we can process an event, we put it there so that you can look at it. But now we introduce destinations, Lambda destinations, and this is really interesting because now when there is an asynchronous invocation, you can say what we should do in case of success or in case of failure. So in case of failure, and you can send the result of the Lambda function in case of success or the error in case of failure to an SQS queue, to an SNS topic, to Event Bridge, or to another Lambda function. So my suggestion is use Event Bridge across different microservices that can be composed of multiple functions. Inside the microservice, then you can use the direct integration between Lambda functions. In this way, you avoid coupling across different microservices. So that's my personal view here. But this is really powerful. For example, it was mentioned by Jeremy, you can send the output of an asynchronous invocation straight to SQS or Event Bridge without writing the code for sending this, because you just configure the Lambda function to send the return to this destination. So without even to write the code for the integration. And this is really making more safe and secure the integration with lots of AWS services that are triggering Lambda asynchronously like S3, if you receive an email using SES, and so on. We also try to improve the experience, as Sarah described, by the way, of consuming ordered streams from Kinesis or DynamoDB streams. These are ordered streams, so if we find an error, we can't just skip the error, because if we want to preserve the order, we need to process everything in order. This can be an important piece of the ordered information. Like if these are updates of a database, you can skip an update and apply that later, because maybe there are other updates that are based on this one. So how can we improve the things here? So as Sarah also shown, so you can now set the number of retries, you can set the maximum, configure the maximum life of these events that we retry. You can also set a destination for an error in a stream. So if there is an error and we fail after a certain number of retries or after a certain amount of time, you can send this to an SQS or SNS topic. But the really nice thing that we gave in your hands is this small checkbox here where you can say, split the batch in case of error. This is really powerful because when you process an ordered streams, you normally process the data in mini batch, like 1,000 events at a time are received by a Lambda function invocation. You process this event in order, there is an error, and the function, you can't manage this error, so the function fails and gives an error. So we can't skip this record because it's an ordered stream. So how can we do? So you can now enable this, and we will automatically retry, not with a single invocation, but we will split the micro batch in 2. So 1,000, we split it in 2, are 2 invocation 500 and 500. Probably if it's a single record creating the problem, it's only in one of the 2 mini batch. So 500 will be processed, and another 500 will have the error. And then we split it in 2 again and retry. And this bifurcation will quickly converge and isolate the poisonous record that is creating the error. So this is really interesting, because then the error that is retried and it's isolated will be sent to the destination that you configure for further analytics. So this is without no code change on your side, and by just retrying and isolating the records will help you isolate the poisonous record. Another concern has been on the Amazon API Gateway. The API Gateway provides lots of it provides a web interface to Lambda function, but it also provides lots of API management functionality. And lots of customers, they actually don't need those functionality. They just want a web interface. So the cost that you perceive is higher than what you expect, because you don't use 80% of the functionality. You just use the web interface. So how can you improve that? So we just launched a new interface that we call the HTTP API. So they say that if you want to hide something very well, you should hide it in the second page of a search engine, because nobody goes there. I think we managed to do that with the name of this feature because it's very hard to look up. But it's called the HTTP API. So now you have 4 options when you create an API with the API gateway. And the HTTP API is something that is currently in preview, but it's cheaper and it's faster than the previous REST API. So if you're building something new and you have some time, explore this new feature. It's simpler to configure, but it's different than the previous experience. And I would suggest you to look at the 2 top options here. So the HTTP API that is in preview, and the WebSockets API to provide a bidirectional communication through using WebSockets. This is really where we are investing in the future. Another way to expose a function to a web interface is the application load balancer. So it's not so popular, but it's actually cheaper than the API gateway if you just need a web interface, you're just producing content that you want to distribute, especially at scale. You pay by the hour here, but if you have lots of volumes, it can be cheaper. So have a look at this. And more recently, we added a feature here that can be really handy, and it's the weighted target groups. So with the ALB, so this application load balancer, you can balance EC2 instances, container, Lambda function, even your on-premise application through IP addresses if you want. And for each of those, you can create a target group. Now you can create multiple target groups and use weights to distribute the traffic across different traffic groups. So that means that you can have a blue traffic group, that is maybe my old serverless application, or even my application running on EC2, and a green target group, that is my new version of the application running on Lambda. And then you can have weights and start to distribute the traffic to the new version and do some check and then roll back if something goes wrong. And you can also do that with the API gateway. But here we have an interesting feature. Since this is a web load balancer, it can automatically implement stickiness. That's something that you can't do with the API gateway. So if you want to be sure that a customer that is reaching the new version of your API is sticking with the new version of your API, is not going round robin between old and new version, you can just do that here. You can enable stickiness from 1 second to 7 days. It's cookie-based, so you must have a client that can respect, that is sending cookies that he receives, but that should be the norm nowadays. And it's really interesting. And you can also configure weighted groups and target groups with lots of options. For example, you can add an HTTP header to the client, like a mobile app that should use a newer version of the API. You configure that in the client, and they will automatically be sent to the newer version. If you have an enterprise application, you can use the source IP to filter the request. So maybe a specific office that comes from an IP range is sent to a different version of the API so that they can test the new version. So it can really be handy for specific use cases. Runtimes. So as I said, people want to use the language they love the most with the version that they want to use. So just before reInvent, so this is November last year, we updated lots of runtimes to a newer version. And we also introduced last year, 2 years ago now almost, custom runtimes. So the possibility to use your own favorite language, like if you want to use Rust, Swift, or all the languages that we can't support for now. It's, of course, more burden on your side, so do that only if you really need. But for example, if you are migrating an application that has specific requirements, you can use a custom runtime to do the migration without changing the platform or the version that you're using. Custom runtimes is the same technology that we are using, so performance-wise is exactly the same as what we can do. It's just that we maintain our runtimes and you have to maintain your own. For the VPC, that has been one of the greatest complaints for the first period of Lambda. As you know, we work a lot to improve that. So now we moved the delay of the creation of the network interface from the execution to the configuration of the function. So now when you configure or update a function, we create the necessary network resources for you. We're using also a different technology, but that's not really important for now. What is the side effect is that there is now no additional latency for functions running connected to a VPC, so you can use more services. For example, if you want to use Elastic Cache or connect to a database, there is really no impact. You will see a delay when you configure or create the function, but that's normally not 10 seconds delay in function creation is probably not a big problem. If you notice, we also introduced now the concept of transitional state in the Lambda function, so you will see that there is a transition of state when you do the configuration, and we implement and we pass it in production. Still, cold start is something that for some specific use cases can create problems. You want to have a commitment to have always the necessary concurrent environments ready to answer. That's why we launched provision concurrency last year. So that means that if you need, you can specify the number of concurrent environments we should set ready. And we will prepare those functions to be ready for the first invocation before any request is forwarded to this environment. So that means that they will answer in the double-digit millisecond time. So it's very, very fast. What is important is that we can only prepare the function to the first invocation. So if you're using some techniques like lazy invocation, so that at the first invocation I'm opening the connection to the database, you will still see this latency. So, and this was quite common in the past. So if you do any lazy setup, waiting for the first invocation before doing something, you should move that before the function invocation so that you prepare everything and the function invocation is really ready to process as fast as possible. This is also integrated with CloudWatch that tells you how much you're using of your concurrent provision throughput with a number between 0 and 1. And you can use this with auto-scaling so that we can automatically scale your provision concurrency based on what you actually do. And this is interesting because provision concurrency has a cost, but the execution cost of functions is lower than non-provision concurrency the function outside of your provision concurrency. So if you fine-tune auto-scaling, you can use provision concurrency basically without any additional cost. If you have a very steady throughput, it can even be slightly cheaper. So think about that. Step function is another interesting building block. One of the great value of serverless is that you automatically decompose a larger application into smaller components, the functions and the interaction with the services. But still, you can build very large and complex function. And complexity is the enemy of speed, because every time something is complex, then when you do an update, you have side effects, and then you have to retest everything. So how can you help you decompose the business logic? We introduced a few years ago step functions that was really meant to decompose a large and long-living business process into steps, like I do an order from a retailer, just a random example from Amazon, and you have to set up the order, check the payments, see that the product is available, start the shipping. The shipping maybe takes 2 days, and you receive updates from the shipping company. So this is very flexible, but sometimes we need to run very fast workloads, and that's why we introduced at the end of last year express workflows. That means that you can now use very high throughput step functions for workflows that last less than 5 minutes. The cost is much cheaper and is based on duration, not state transitions. So this can really help you decompose any complex business process in smaller components that you can then coordinate with a step function. It's much, much cheaper, and it's also very fast. So have a look at this, and if you see a function that grows too much in complexity, this can probably help. Jeremy already talked about the relational database service integration with the new RDS proxy. If you have a legacy application, or if you have some data that for some reason you want to keep on a relational database, the RDS proxy that is currently in preview can really help, because it's managing for you connection pooling so that you use your relational database efficiently. Is managing failovers automatically in case of failover of the database. And it's also improving security because it's automatically implementing IAM for identity and access management. And it's also using Secrets Manager for the management of the credentials to access the database. And Secret Manager can also help you automatically rotate credentials if you have compliance, or just for security is a very good practice. And I think that RDS proxy and Aurora Serverless is really an interesting match for specific workloads. This is some test that I did when we launched Serverless Postgres. And this is an example of how the database was scaling up vertically automatically with my load. Then I also enabled the feature to automatically pause the database if there was no load. And you see the pause. And then when I start again, it restarts as I was left. And then as my workload was going down, the database was shrinking. And since you pay for the CPU based on the vertical dimension of this graphic, is really interesting. If you have a batch workload, the auto pause feature is really interesting, because when you receive a batch workload, this will start, recover the database as you left, use it for as much time as you need, and then when it's shut down, you only pay for the storage and you don't pay for the database CPU anymore. Event Bridge is a service that today has been mentioned a lot, and I'm very happy about that, because events, as I said at the beginning, is an important component of serverless architecture. And we launched a couple of features recently that can help. One is the integration with CloudWatch alarms. Now, if you create an alarm from CloudWatch that can be based on infrastructure metrics or business metrics, you can trigger something using Event Bridge. And the other one is the schema registry that allows you to integrate also with third parties. So this is an example of MongoDB, the fully managed service from MongoDB, so an external service. And here you can say, hey, this is my database, my collection. I want to receive notification if there are updates or deletes or something in this collection, in this AWS account and in this region. This will automatically send the data to your event bus, Event Bridge, and the schema will be automatically discovered by Event Bridge, so you can see what is the discovered schema, what are the fields based on the collection that you're sending from MongoDB, so your own specific data. And this is also implemented inside the AWS toolkit that we launched for multiple IDE, like VS Code or IntelliJ in this case. And you can browse the schema from within the IDE, so as is sent. And if you want, you can also use this, especially with a strongly typed language like Java, in your code. So when you're writing your Java code, you can say, hey, I want to receive this event from this event bus. I know that this event is coming from MongoDB, and the data type will automatically expand and show you what is the full document that you can receive, and also inside the document all the fields of the MongoDB collection. So it's really handy and helps you, again, to integrate with external services in a seamless way. When I talk of serverless and I want to give an example that is not Lambda, one of my favorite examples is Amazon Athena. It's a way where you can run SQL queries on any file on S3 we support different data model, and it's really interesting. What we launched recently is that you can now create user-defined functions using Lambda and reach basically any data that can be reached by Lambda. We provide you a few integrations, and then you can add your own customization. That means that you can now run SQL queries on CloudWatch logs if you want. You can run SQL queries on DynamoDB. And you can also add your own integration, writing your own Lambda function that is then used as a user function by Athena. This is currently in preview. It's available only in a couple of regions, I think. But again, when something is in preview, it's the best time for you to experience and provide your feedback to us so that we can also improve before the general availability. Another service that we didn't talk a lot about today is Amplify. It's a platform that is great for front-end and full-stack developer. And we launched a couple of interesting things here that can help build native mobile apps better, because we launched Amplify for native iOS and Android, and not on top of the JavaScript and hybrid architecture that were supported before. And we also launched the Amplify Data Store. That is a storage that lives inside the mobile device, and we automatically can synchronize this across devices or with the cloud. So it's really an interesting way of building simple application in a simpler way. Just last night, we launched the adapter for React Native. So if you are a React Native developer, it was launched exactly during the night before. AppSync is one of the very cool services that we launched in the last years that helps you manage a GraphQL interface and translate SQL queries and GraphQL queries and GraphQL mutations in the backend. And we launched a couple of things here. One is was launched last week, and it's the GraphQL info object. So when you run a GraphQL query, you can specify, for example, the number of fields that you want to get. It's mandatory with GraphQL which fields you want to get to be specified in every query. Now this kind of information on the structure of the query are sent to the resolver that can be a Lambda function, and you can use this information to optimize your request. So for example, if I don't ask in my GraphQL query a specific field, then maybe the Lambda function implementing the resolver doesn't need to go to a specific database, can simplify the query, can optimize the query. So this is interesting information, and now it's passed along with the GraphQL query to the resolver. And we also completely re-implemented at the end of last year the way we manage WebSockets for GraphQL subscriptions, so to give updates on the GraphQL mutations. We created a new implementation that is highly scalable. This is just a quick test that we did up to 10 million concurrent connection to a single AppSync endpoint. One thing that is interesting with serverless is also configuration management. Since it's a distributed architecture, how can I manage my configuration? So here we added a new option, and then I will do a review of the possible options. So this is AppConfig that was launched quietly at reInvent. It's one of the, it comes from an experience internal to Amazon, and the idea is I would like to launch, to manage configuration changes in a way similar to the way I deploy new version of my application. So to monitor, distribute slowly a new application configuration and roll back automatically if a configuration is broken. So with AppConfig, you can create a different application managed by AppConfig. This is internal to the service. Then for each application, you can create multiple environments like dev, test, and prod. And then you can create a configuration profile with the specific configuration, like this is the credential that you should use, or this is the number of things that you should implement in your application, so any parameter you want. And then you can apply a configuration profile to a specific environment, like in dev, then in test, then in prod. Roll back this slowly to the different clients. Can be Lambda function, but can also be containers. And you can implement, using a Lambda function, a check of the syntax of the configuration, so that before the rollout, there is a strict control on the kind of configuration that you're rolling out. And you can set up alarms, CloudWatch alarms, that automatically roll back a deployment in case of errors. So it's really an interesting way of deploying configuration changes. So now with Lambda function, you can use these 4 options. So if anything is specific to a single function, I would suggest use environmental variables. It's the environment variables. If you have shared parameters, the parameter store is probably the best way to do so. For secrets, the secret manager adds the necessary security and normally the possibility to rotate the secrets automatically. And if you want tight control on rolling out configuration changes, then have a look at the new AWS AppConfig. Observability is very important. Again, it's been talk about that today. We also have Lumigo here, that it's a great partner in that area. And we also try to improve here. So tracing, the possibility of understanding how applications the flow of the interaction works in a distributed architecture. So here we added more services. So SQS and SNS are supported by X-Ray. Amazon API Gateways have been supported since 2 years ago, but we just launched last week AppSync that is now supported by X-Ray. And also monitoring. We improved a lot on our CloudWatch platform. So there's a few things here that I would like to show. So first thing is this embedded metric format. So if you want to create a custom metric from a Lambda function, it's always been complex because when you normally create a monitoring metric, you don't want to update the metric every time the number changes. You want to do a batch update, like every 10,000 requests, I want to update the metric. You can't do that from a Lambda function because we create and destroy environments for you, so you can't batch data and then send it. So you can now use this embedded metric format. That means that if you write the logs on CloudWatch logs with a specific syntax, we automatically create a metric out of that log for you. So it's completely asynchronous. You don't need to manage the creation. And to make it simple, we also created 2 libraries for Node.js and for Python that you can use to write, to publish a metric. So and you can create business metrics like this is the number of orders that I received from this function, this is the number of transactions that I'm doing, the number of search in my product catalog. And all these metrics will be automatically transformed into a CloudWatch metrics from the logs automatically. You just need to use this API. CloudWatch Synthetics, that is in preview, is a service that allows you to monitor your service in a simple way. So you can create heartbeats. You can create, if you want, you can check if there's broken links, or you can also create a multi-step canary check of a multi-step operation. So you start with a blueprint, depending on what you want to monitor for your application. And we provide some starting code that is JavaScript-based that then you can customize. And in this way, you can periodically check if your application is working. And if there is any problem, you can receive a notification or an alarm. Service lens is another component of CloudWatch that we introduced to help you bridge the information from traces with logs and metrics. So now if you have a trace of your architecture on X-ray, you can go on Service Lens, you see the same trace, but if you click on any node, you will automatically drill down into the metrics and the logs of that specific component. So you can really drill down and isolate a problem quickly. And also at the end of last year, we introduced relatively quietly anomaly detection into CloudWatch. That means that for any metric, you can now enable anomaly detection. We will use the last 2 weeks to understand which is the pattern of this metric. It can be, again, a custom business metric or can be any infrastructure metric. And then you can create an alarm. And when you create an alarm, basically you can say, hey, notify me if your apps outside of this of the standard pattern that we expect, only if I'm above or only if I'm below. And you can also set the number of standard deviations. That means the width of the bandwidth, so of the band. So in this way, you can really recognize this unexpected behavior from your application. And you can use that in any integration where CloudWatch Alarms works. So for example, during a deployment, if my number of sales per minute drops down, means that my deployment broke a business metric, then automatically I want to roll back, and then I will investigate what happened. So you can really do cool things with anomaly detection. So lots of things have been addressed, and lots of concerns have been addressed solved in the last few months. So we really focus on helping you use serverless in a better way. And also, lots of new and interesting tooling is coming from our partners. So Lumigo was here, Tandra was also sponsoring the event today. Our partners are doing an amazing job in making easier to build a serverless application. One thing that is coming soon that is also interesting for the cost side is savings plan. So this is something we introduced last year for EC2 and Fargate. We are going soon to expand that to Lambda functions. So that means that you can buy compute from AWS, and then you can decide to spend this compute on virtual servers, on containers, or serverless without having to plan that in advance. It will really make it flexible and also optimize your cost a little bit more. This week, I think we launched the integration with of the serverless lens in the well-architected tool. So if you build a serverless application and you want to know if you're building the right thing, you can now use this free tool in the AWS console. It's a self-assessment where you are asked questions. And now you can apply the serverless lens that will automatically ask you additional questions that are specific to serverless workloads. And for each question, you can specify where you are, like I'm at this level implementing tracing or monitoring of my application. And for any gap, we will provide you the necessary suggestion on how you can implement what's missing and which tools you should use. Important to show that the questions and the answers are cloud agnostic, so you can use that also for anything running even on premise if you want. The implementation plan is AWS specific, so you can self-assess anything, and then the suggestions we make are AWS specific. So with serverless, you can really do lots of interesting use cases. So this is iRobot, the vacuum cleaner. This is the serverless architecture they use when you turn on for the first time one of these Roomba devices that they sell, the vacuum cleaners. And it's completely serverless. They use API gateway, SQS, Lambda functions. And this is well architected. And one way to know that it's well architected is by listening to Ben Keough. That is one of the serverless heroes that we have. He's telling us that they sell millions of these. They sell millions of these, but most of them are turned on in 4 hours during Christmas morning. So most of the traffic happens in these 4 hours. It's a 100 times more load than what they have during the year. And since everything is serverless, for them is a normal business day. Everything is automatically managed by the platform. This is the power of serverless, focusing on what you want to build, not managing the infrastructure. So what can you do with serverless now? Lots of things. So you can do mobile IoT, web backends. You can do analytics. You can automate your DevOps scripts. You can build voice or text interfaces. You can now build real-time applications and even start to think about backend for multiplayer games. You can architect complex asynchronous architectures based on events or notifications. You can reduce your cost even more with the feature that we put in. You can also reduce complexity even more. And you can really do whatever you want. So I think at this point, I think it's clear that the title of my session was wrong. So it's not really important what you can do with serverless, but it's important what you're going to build. Thank you.